Okay, good afternoon, everyone. Let's start now. Good afternoon, everyone. Welcome here. Okay, right. You guys still remember or not? Last week, what you learned, in lesson 2. What is the title of your lesson 2? Can someone tell me now? What is the topic in lesson 2 last week? Jin Yi Hong, Jin Yi Hong, are you there? Jin Yi Hong. No sound. Okay, Kian Leong, are you there?
Yes.
Can you tell me now? What is the topic of what last lesson? Do you remember? Last lesson?
Specific heat capacity.
Yes, correct. Specific heat capacity, right? The title is specific heat capacity, right? Okay, now my next question now. What is the meaning of that? What is the meaning of specific heat capacity? Nicole? Nicola, are you there now? What is the
Yes.
meaning of specific heat capacity?
The amount of heat required to raise the temperature of 1 kg of substance through a temperature of 1 degree.
Yes, very good answer. Thank you, Nicole. Amount of heat required to raise the temperature of 1 kilogram of substance by 1 degree. It must be 1 kilo, 1 degree because it's specific. Understand? Okay. Then you also learned the experiment last week, right? The experiment to determine the specific heat capacity of solid, which is aluminum, and also determine the specific heat capacity of liquid, which is water, right? Okay, I think most of them are here already. Okay, come. Let's look at the paper now. Okay. Okay, your paper should be here. Okay, okay, roughly I go through very, very fast for what you have learned already. Okay. First is regarding this experiment, right? The experiment determine. Yeah, now still got people come in. When I start, got people come in. Okay, who want? Let them come in first, Okay, this is an experiment, right? Determine the specific capacity for aluminum, right? So you do like this. So our calculation is use this formula, C equal to PT divided by M theta. Get the power, multiply the time, divide by the mass of the aluminum, which is 1 kilo, right? And multiply the change in temperature. So you calculate, so you get the answer, specific heat capacity. For example, here we get 2,400, okay, which is not accurate one now. The answer in the experiment is not accurate one, It's not accurate. It's not accurate, but it must be bigger than the standard values of specific capacity or not. Okay, I say it again now. The answer we obtained from the experiment specific capacity for aluminum, right, is 2004. This answer memang is not accurate one, but it must be larger than the standard values of specific capacity of aluminum. Okay, why the answer must be larger? Why? Can anyone explain why the answer must be larger? Very important, you must know this, Your answer must be larger than the standard value. Cannot be the same. Must be larger. Why? Why must be larger? Carmen, can you try to answer why must be larger than the standard value? Why must be larger than the standard value, Carmen? Carmen, well, the answer is here, The explanation is somewhere here. It must be larger. No, you see here, you can read here now. Why must be larger? Okay. Why must be larger? Your answer lah. Can you answer lah? Why must be like here the answer?
Because got heat loss.
Yes, because got heat loss, right? When heat is lost, no matter how you cover using cloth or using tissue, heat loss still can happen, right? When heat loss, right, so the rise in the temperature, the theta will become less than the expected value. It's supposed to be the temperature raised up by 30 degrees, but it never achieved 30, maybe achieve 25 degrees only, because a part of the heat are lost. So because you look at this formula, this is a formula we learned, right? When this value theta becomes smaller, right? Theta becomes smaller. When you calculate, you will get this specific capacity C become larger, become bigger, right? Not? Okay, this is the reason you know. Okay, another experiment you have gone through here is determine the specific capacity of liquid water. You also do the same thing, right? Also same lah, the same calculation lah. I don't want to repeat lah. Okay, and after this, we discuss a few examples of natural phenomena involving specific heat capacity. For example, this one, in cooking instrument, cooking utensil, correct not? The body of the frying pan must make from small specific capacity material. Example is steel. Why? Because this part can heat up faster. When small specific capacity means can heat up faster. Whereas the handle, right? Handle must make from material with large specific capacity, difficult to heat up. Okay? So easy to hold, correct not? Okay? Then another example is a heater. In a heater, right? In a heater, we use water to carry a lot of heat energy because water has big specific capacity. So it can store a lot of heat and carry the heat to the room, and to the room, when the fan blows inside the room, right, it can release the heat, right? So it can heat up the room faster lah. Use water. One, water is cheap, and also water specific capacity big, so you can carry a lot of heat energy. So it's good, okay? Okay, another one you learn is radiator in a car. Okay, you can remember or not? Yeah, you see in the car, right? Inside the car also we use water to circulate the engine. You see here? The water is pumped through the engine, right, to absorb the heat, to cool down the temperature of the hot engine, correct or not? Once again, why choose water? Okay, the reason is water has large specific capacity. Large specific capacity means it can store the heat, the temperature increase only a little bit. So it's very good in absorbing the heat lah. So we use water. Okay, hot water come out here, go here, then release the heat here. Okay, and finally you learn this, right? This is land brace, sea brace. Okay, I don't want to explain already lah. Sea brace, land brace. Okay, sea brace happen during daytime. The wind blow from the sea towards the land, so it's sea brace during the daytime. Nighttime is land brace. Land brace means that during nighttime the wind blow from the land towards the sea. Okay, this one you must roughly know like this. Okay. For those who did not join the lesson, I just go through very fast now. Okay, during daytime, the land get heat up very fast because lands are small specific capacity. So land can heat up very fast during daytime. So it becomes very hot. So the hot air here rises up. So hot air rises up. So here empty, right? So then the cool air from the sea will come in, will move in to occupy this empty space, right? So this makes the air move from the sea to the land. So this is land, sea brace during the daytime. Okay, nighttime, same thing. Lands are small specific capacity, can heat up fast during the day. Nighttime, we can cool down fast also. Okay, remember now, when specific capacity is small means that it can heat up fast and also it can cool down fast. So at night, it can cool down very fast. So land become cooler, right? Compared to the sea, sea water at night is still hot, is warm. So here, the air hot air rises up, so the hot air go up, so here empty, right? Then the cool air from the land will move in here to occupy the place. So this make the air move from the land towards the sea during the night, so it's called land breeze, okay? All right, and then we have finished question 1 to question 9, our last lesson, right? Okay, now supposed to be question 10. Okay, look at question number 10. Okay, question number 10. You see the answer? How to calculate? What is the specific heat capacity of the liquid? Okay, because the liquid is heat by using a heater, right? Heater is 0.4 kilowatt. The mass is 0.2. Our formula is PT equal to MC theta. Power multiplied time equal to mass, specific capacity, and theta. So you want to find the C, right? Power is 400, okay? 0.4 kilo means 400 watt. Time, okay, time you take from here. Okay? You take the whole graph. So the time is 0 to 40 seconds. So 40 seconds. Take the whole thing. So time 40 seconds. Okay? And the mass 0.2, right? C, you don't know, you ask to find. Theta, okay, theta get it from where? Change in temperature. Okay, from time 0 to 40, right? So the temperature is moving from 5 to 85. Mean the change in temperature is 80, right? 80 degree. So you put it here. So you calculate the C, you get 1000. Okay? So for this question number 10, the answer is 1000. Please jot down. Okay? Okay. Jot down it. Okay, faster. Let me take out the pen. All right. Okay, question 11. Now, 11. The value of specific capacity of a substance determined from experiment is larger than standard value. Larger, the reason is the temperature rise less than expected temperature rise. This value smaller than the expected value because heat lost to the surrounding. So this theta becomes small. So when you divide by a small number, your answer C becomes big. So that is the reason. Okay, number 12. Which of the following is true? All right. Cooking. Okay, for cooking utensil must use low specific capacity, so can heat up faster, right? When the handle must use high specific heat capacity material, difficult to heat up, so the handle will not get hot. But the cooking utensil with low specific capacity, you can heat up very fast. So very fast can cook. Okay, so answer B. Okay, 13. Not related to specific heat capacity. So which one not? So refrigerator. Refrigerator, right? We didn't study this, right? Refrigerator is related with evaporation. Can you write it down? Evaporation. For refrigerator is involved evaporator. Okay, evaporator. Okay, not involving heat capacity lah. Okay, the one involve heat capacity one radiator. You have learned that, right? Radiator, cooking instrument, land brace, sea brace, all these involving specific capacity, except refrigerator. But you must know in the fridge, right, involve evaporation, okay? Evaporation of certain chemical inside the fridge, okay? Yeah, later on in higher level, you will study that. Okay, all right, next question. Question 14, okay? This one is a structure question. The block P, okay, P, Q have the same mass. Their masses are the same one. They are immersed in the boiling water. Put it inside the boiling water. Boiling water means the temperature is 100 degrees, very, very hot for a long time. For a long time means definitely this block P and Q temperature also become 100. Okay. PQ then transfer into the beaker. Then this one transfer into here, put inside the water to heat up the water. Whereas this block Q, put it inside the water here to heat up the water here, lah, right? Okay. So now transfer to beaker X, and then what happened is the mass of water here, the water here and here same, 0.25 kilogram. Initial temperature also the same, okay? But what happened was, you see what happened? Now, specific capacity of P 900, 900. This 900 means can store more heat. Bigger specific heat capacity, it can store more heat. Okay, also can transfer more heat here, lah, right? This one's specific capacity smaller means store less heat. So less heat transfer here. Definitely the water here become hotter, temperature become higher. The water here temperature is lower because big specific capacity, right? This thing, so you can carry more heat over here. I can store more heat and then transfer the heat over here, lah. More heat transfer here. So the water temperature is higher, expected. Okay, now see the initial temperature of block 100. Okay, is 100 degree. Initial temperature is 100. Why 100 then? Because in the boiling water, right? Right. Okay, next. Why is the final temperature of beaker X higher than beaker Y? You said here, temperature higher than here. I told you, right? This specific capacity is larger, So it's larger means block P transfer more heat. It carry more heat and transfer to the water. That's why the water is hotter. Okay. Larger heat capacity, store more heat, transfer more heat over here. Okay, understand? Okay, next. Calculate the rise in the temperature of water beaker Y here now. Okay. If block Q release this number of heat, okay, use this formula. Q go to MC theta. Q given the block Q, right, transfer 8,400 joule energy. Mass of the block 0.25. C is water, right? Water, specific capacity of water 4,200. Okay, 5 change in temperature, so it's 8 degrees Celsius. So meaning that the water in beaker Y only increased by 8 degrees Celsius. Okay, got it? Got the answer already? Okay, copy down the answer. Any question to ask or not? You all? Anything? Anyone want to ask any question? Or very quiet only? Let's meet Chong. Any question to ask?
No, teacher.
No question. Okay. Kian Liang, anything to ask or not? Kian Liang?
No.
No. Justin? Okay, Justin?
Okay.
Okay, Okay, then we move on to the next part. Okay, next part of the question. Sorry, I have to move this thing left, right, okay. Next. One assumption, okay. Assumption is this answer. Why? No heat lost to the surrounding. Why the answer is this one, no heat lost to the surrounding? Why our assumption is like this? Okay, let me explain. You all listen. Why our assumption is no heat loss to the surrounding? The assumption is here now. This one, even in the SPM, they ask you, what is your assumption? Okay, our assumption is this, This block P and block Q absorb the heat from this hot water, right? So then it store the heat here, then transfer the heat to heat up the water. Transfer the heat to here to heat up the water here. Okay, what if we assume? We assume all the heat energy carried by the block are used to heat up the water. No heat lost to the surrounding. That is our assumption, So our assumption, we say all the heat energy transfer here is not lost to the surrounding. All used to heat up the water here. All the heat transferred by block Q used to heat up the water. Understand? No heat loss to the surrounding. This is our assumption now. Because we put the formula Q equal to MC theta ma. Q, heat carried by block P and Q, right? So Q equal to MC theta. So we assume the Q, the energy carried by the block P and Q. So we put the formula Q equal MC theta. MC theta is a heat absorbed by the water. When we use this formula, class, just now, no? When you write Q equal to MC theta, this Q means is a heat come from the block. Then you say the heat equal to MC theta. MC theta means a heat absorbed by the water. So we say all the heat transfer equal to the heat absorbed by the water. So no heat loss to the surrounding now, which is actually not true one, you know. That's why we say assumption. We assume it. Understand? Okay, Okay, understand. Okay, next one. Next is question 15. Okay. They say question or this one you need to prepare to skip people. Okay. Diagram show 1.5 kilogram of water. So here got 1.5 kilogram water pour into a metal container. This is a container, very thick. Now see the metal. Mass 2.0 kilogram. This metal also very heavy, 2 kilo. The water 2.5 kilo. This metal 2 kilo. Initial temperature of water containers are 28 degree room temperature. Okay. Electric heater power 0.08 kilowatt. This is a heater, right? Take 10 minutes to heat up the water to 34. Okay, means to heat up the water and also the container same temperature one to 34 degree. Means the temperature only increases by 6 degree only from 28 go to 34. Okay. Yeah. And now calculate the total heat released by the heater Q equal to PT, right? Energy come from the heater is power multiplied time PT. Power 80. Where do you get 80 then? 0.0 times 1000 kilowatt, right? So it's 80 watt. Time is 10 minutes, right? Change to second. So you get 48,000 joule. This is a heat energy produced by the heater. Okay. Now the next specific capacity of water is 4,002. Okay, water Then they ask you to calculate heat absorbed by the water. Okay, so Q equal to MC theta formula. Mass of water 1.5. C specific capacity for water 4,002. Theta 6. Just now I told you, right? 6 degree. From 28 go up to 34, so 6 degree So you get 37,800 joule. You see, it's different, you know. Heater produce 48,000, but the water only absorb 37,800. Then the rest of the heat go away. You see, this heater produces 48,000 joule energy, but the water only absorb 37,800 joule. Then the rest, the remaining of the heat go away Nicole Chua, the remaining of the heat go away Nicole.
Go
I
to
see
the
on here,
metal
that's why I call you.
Go to the metal container.
Yes, correct. Go to the metal container. The metal container absorb the remaining heat, right? So you just minus right? Take total heat minus the one absorbed by water, so you get this So this will go to the metal container, okay? This one is a heat absorbed by water, and this one is a heat absorbed by the container, right? Okay. And now I got one question I want to ask you guys here. See, I see whether you know or not. Both the water and the container, the temperature increases by 6 degrees, right? 28 to 34, right? Not? But how come water absorb more heat, but the container only absorb 102,000 joule? Why container absorb less? Why the water need to absorb a lot of heat? temperature go up same มา 28 go to 34. Why? Why that? Why the container need absorb less heat compared to the water? Huh? Justin, can you answer? Justin, try. Justin?
If the metal container absorb more heat energy, the water may evaporate or dry.
No more, you
Because
see, water absorb 37,800 but container only absorb 10,200. Why metal absorb less heat for the same rise in the temperature, 6 degree, 28 degree to 34? Why the container absorb less heat, whereas the water absorb more heat? And why?
Because
what is the reason?
Heat, because of heat capacity.
Yes, correct. Can you explain a little bit?
The metal container have small heat capacity.
Yes,
than the
correct.
water.
Very good. Very good. Okay, the metal container the metal specific capacity is smaller. Smaller means easy to heat up. So you need less energy to heat up because it's easy to heat up So lesser energy needed to heat up 6 degrees. That's why absorb less. Whereas a water specific capacity is big, 4,200. So to increase 6 degrees, water need more heat energy because specific capacity is big. Specific capacity big means difficult to heat up. Difficult to heat up means need to absorb more heat. More heat absorbed to increase the temperature. Understand? This kind of thing you all must know. Okay. Yeah, especially if you want to score A+ or A, you must understand every single concept deep into detail. You must understand everything very deep, okay, into the detail. If you only understand the surface only not enough one, You only answer the surface, the surface concept, right? The most you can get is B+, A- like that. You want to get A+, you have to understand more in detail. Understand? If you follow my lesson, normally my lesson I will teach in very detailed one. Okay? But you need a lot of patience to listen to me. Okay? Because especially I teach very detailed, very deep sometimes, right? Some students, they feel it very boring. Say, I'm very chiong. Hey, I talk a lot. I understand one, okay? Actually, I'm trying to be more detailed. You have to be very patient to follow my lesson, okay? All right, next. What is the specific capacity of metal? Okay, so use this formula, Q go to MC theta. Okay, heat absorbed by metal 10200. Okay, mass 2 kilo. C, you are asked to find the metal container C, right? Theta increase in temperature 6, then you get 850 joule per kilogram per degree Celsius. Pay attention to the unit. Now you see the metal container specific capacity smaller, only 850. Water is 4,200. For water, the value you must remember one, 4,200 for water. Then for metal, 850. Less, okay? Joule per kilogram per degree Celsius. Yeah. Okay, let me see how what happened to you all already now. Yong Jia Wei, okay or not? Yong Jia Wei. So far?
Okay, sir.
Yes, sir. Okay. Tan Shirley, okay or not? Tan Shirley?
Yes, sir.
Okay, good. Darren To? Darren, are you there? Darren no sound. Chai Pei Sin, are you there? Chai Pei Sin? Also no sound. Chai Pei Sin? Lim Ching Wen, Lim Ching Wen? Lim Ching Wen, anything to ask?
No.
No, okay, I can understand now. Chua, Wen. Chua, are you there now? Chua? This I don't know some. Some ask me to add in the group, say want to follow, but I say tonight never come in also. You want to see this go even. Okay. One more question to go, So many of you type them, what is that? Yeah, I cannot see you. Okay, one more question to go. Come, we move on. Number 17, okay? The question number 17. You ask a big question now. Don't just every time I talk, you're very quiet now, very passive. Okay, read the question. This is a container for keeping food warm, okay? It's something like a thermos to keep the food warm, right? The container is able to maintain the temperature for a long time. It can keep the heat long. Container can move from one place to another, means that the container must be light, because it need to move from one place to another, Okay, so it must be light. Okay, now the question is, the following table show the characteristics of material would be used to make the food container. One is the density, just like I say, right? Density, because this thing need to be light, because easy to move along, isn't it? So the density must be small density one. Density small means it will be lighter, right? And what about the melting point there? Melting point, the material, melting point, the material. Okay, you see here now, this container need to keep food warm, meaning that it must be high melting point. Not easy to melt, correct? Not easy to melt, because always keep the hot food inside. The melting point must be high, not easy melt, not good. Okay, then next one, specific capacity. What about specific capacity? How to see? Okay, now you see, specific capacity usually a container keep the food warm means we won't get heat up easily. When the container itself must be not easy to get heat up fast, because when you put hot food inside, if the container become very hot very fast, I mean the container become hot very fast means the container can lose the heat to the surrounding very fast, then the food will cool down very fast, that means no good. So you must pick some material of the container which is not easy to get hot, not easy to heat up one. So not easy to heat up means that you won't absorb the heat from the food, right? Not easy to heat up, so you won't get hot. If not hot means that the heat won't go to the surrounding, won't lose the heat, right? So you must choose the last specific capacity one, pick one, okay? And thermal conductivity, the ability to conduct heat. Thermal is heat. Okay, definitely the thermal conductivity must be very low, very bad. We don't want this thing to conduct heat actually. If good in conducting heat means the heat can run away very fast, no good, right? Okay, your radiography, you know the answer is R, right? Okay, later on I tell you why. Okay, now what is meant by melting point? Melting point is what? What is melting point? Melting point, how to answer it? Melting point. Yao Ping Hao. Ping Hao, are you there?
Yes, sir.
Can you try what is the meaning of melting point? Melting point is what? What is melting
temperature,
point?
the temperature that an object changed from solid state into liquid state.
Yes, correct. Very good answer. It's a temperature, okay? No, it's here, the temperature. This is a temperature where a material start changing from solid to liquid. Okay. Now see, sorry, I need to close this one first. Okay, now can see, right? I open up the window picker. Okay. Okay. Melting point is a temperature where a material start changing from solid to liquid. Okay, you want to understand all? Right? Okay. Now question 2. Look at the question. You are asked to investigate the characteristics of the material. Okay, it could be used to make the food container. Explain the suitability for each characteristic. Okay, and finally, justify your answer. Justify your answer means you have to choose one. Which one? Okay, this part is 10-mark question, 10 marks. So you need to answer in a table. Okay, in a table you divide it into 2 columns like this. Okay, you see, like that. Okay, on the left side is your suggestions. On the right side, you state the reason why you suggest like that. Okay, so you follow the spec given in the question. Okay, so the first one is density. Okay, we choose low density material. Okay, then you keep the reason because the container is lighter and easy to carry. The reason. Okay, please jot down the answer. Low density material will make the container lighter, so easy to carry. Correct not? Okay, the second part is melting point. Just now we say high melting point, right? Okay, high melting point, you have to be careful a bit. High melting point doesn't mean we need to choose 3,800 or 2,700. Why? In this world, there's no food has this high temperature as high as 3,800 one. No. The most the normal food, normally the temperature is 100 or 100 plus a little bit only, right? Food. Where got food, the temperature 3,800 degree one. No. No, I think we choose this temperature enough already. Sorry. No food temperature, the temperature is 2,000 over 1, right? No need to choose this one. I think we choose 240 enough already. Okay. Most of our food or even soup, temperature is only 100 plus, only 100, sometimes below 100, correct not? So 240 as melting point is good enough already. It's good enough to withstand the food temperature, 240 can already, okay? But we still put there high melting point, okay? High melting point. Okay, let me clarify to you, class. In answer the SPM question, we normally we say you choose either high or low. No, we don't choose medium answer one, Normally here you choose either it's low or you choose high. You don't choose medium. No, never happen one. You either state low or you state high. Don't choose medium. Okay, no medium one. So we choose high temperature. Okay, the reason is not easy to melt by the high temperature of the food. Okay, the reason we choose high temperature, 240 enough one. Not easy to melt by the high temperature of the food, correct not? Yeah. Okay, number 3, specific capacity must be high. High specific capacity material. Reason, not easy to be heat up, so can reduce the heat loss. So meaning that the container will not get heat up. So not heat up means can reduce the heat loss to the surrounding. Okay, that is what you want. You want to keep the heat inside the food. Don't want the heat lost by the container, isn't it? Okay, not easy to be heat up, then you can reduce the heat loss. Okay, all right, and then the last one, low thermal conductivity, right? The reason is reduce heat loss through conduction. When the heat conductivity is very low, means heat not easy to conduct, not easy to lose heat through conduction. Okay, that is the reason. Okay, by writing this, you only get 8 marks only now. See, 1, 2, 3, 4, 1, 2, 3, 4, so 8 marks. So the final 2 marks, you must write your conclusion, justify your answer, the person say, right? So it's like this. The most suitable material is R, 1 mark. You must choose the correct one, R. Then you repeat the reason now, because it has low density, high melting point. We choose just now low density, high melting point, high specific heat capacity, correct not? And low thermal conductivity. And then the last part give you the final marks now. Okay. So altogether 10 marks. Okay, come take down the answer. Yeah. Chua Michelle, are you there? Chua Michelle Chua?
Yes, sir.
Do you
Yes.
understand? Do you understand or not?
I understand.
Understand, Caleb? Caleb, are you there? Caleb?
Yes, sir.
You understand, Caleb?
Yes.
Then, McNish? Hello, McNish, are you there?
Yes, sir. Yeah.
You understand?
Yes, sir.
Then,
Yeah.
okay, good. Yuling? Yuling, are you there?
Yes, sir.
Yuling, any question or not?
Sir, may I know why we cannot choose Q?
Why cannot choose Q? Okay, let me see. Why cannot choose Q? Q because the melting point 27 Yuling. 27 cannot because food definitely will melt. Like soup, sometimes food temperature higher than this now. So the melting point 27 means you put any hot food inside, so the thing melted already. Understand? It's because melting point too low, cannot. This one too low already, Yuling. Understand?
Can, sir.
27 cannot. Normally food, hot food, right? Normally is the temperature is around 100 degrees, right? So must have minimum 100 degree the melting point. Okay, understand? Okay, any more question? Juling, any more question? It's good that you ask, Juling, good.
No, sir. Thank you, sir.
No more, Other student, any question to ask? Zhao Xiang, any question to ask? Jia Wei, any question to ask?
No, sir.
No, sir. Kevin Lim, any question to ask or not? Kevin?
No, sir.
No, sir. Very fast. Okay. All right, come. The last part of the question is calculation. Now the answer I just show you here. Okay, come back. Last part still got one part, So the last part is here, calculation. Okay. 500 grams of hot water, 90 degrees. Right? Pour into a glass and left to cool down to room temperature 30 means when you left the hot water on the table, it will cool down from 90 degrees, it will cool down to 30 degrees, correct not? Sketch a temperature time graph, okay? Temperature, time, okay? Can understand now? I will move a little bit. Yeah. Now, here is temperature. Here is time. Time be logical, be don't put second now. Second cannot put minute at least. You want to see the temperature change of the water, right? Must be minute now. So the water's temperature start from 90. So you drop, you keep on dropping, drop until 30, then it stop already, right? Because surrounding temperature is 30, right? 30. When it's 30 already, so it becomes stable. Why it becomes stable? Why when the temperature drop to 30, then becomes stable? Because thermal equilibrium happen. Correct not? Thermal equilibrium between the water and the surrounding. Between the water and the surrounding. When the surrounding temperature is 30, so the most the water temperature can drop to 30 degrees because equilibrium already, right? So when equilibrium reach already means the temperature of the water and the surrounding become the same. So which is 30 degrees. So make sure this part also you understand, why it becomes stable. Okay. And the last part calculation, these are I think very simple. Calculate the quantity of heat loss from the water, okay? MC theta. You want to find heat absorbed, heat loss, all use the same formula one, MC theta. Mass of the water 0.5, specific capacity water 4,002, theta 60. Why 60? Because from 90 drop to 30, right? Change in temperature is 60. So you calculate, you get this. Okay? So this is the number of amount of heat energy lost by the hot water to the surrounding. Okay. All right. So we have finished this set of paper already. Okay. No more question. We finish already. Okay. Come, let me see. I cannot see your face. Most of you never show face one. Yu Tong, any question or not? Yu Tong. Now I see your name here. Yu Tong. Ngu Yu Tong, any question?
No, sir.
No, sir. Everything understand? Yu Tong.
Understand.
Sure or not? Everything now understand very good. Zhong Chao Yi. Zhong Chao Yi, any question? Zhong Chao Yi. Lu Sao. Hashini. Hashini, any question?
No, sir.
Everything understand? Hashini.
Yes, sir.
Hashini very good. This smart girl very good. Okay. Kong Fan Sin, any question to ask? Kong?
No, sir.
No question. Okay, good. Ati Subramaniam, any question? Ati? Lu Sao. Yi Mei Hui, any question? Yi Mei Hui? Mei Hui, any question or not? Ong Jia Sin, anything to ask? Ong Jia Sin, anything to ask?
No, teacher.
Have you copied down all the answers, Jia Sin?
Yes.
Yeah, okay, good. Sharis, any question? Anything to ask or not?
No, sir.
No, sir. All these are no, sir. I see the good friend, Cicely. Any question to ask, Cicely?
No.
No, I see. No, obviously no, sir. Yes, sir. Okay lah. Rest 1 minute, then later on we move on lah. Move on to someone asked question here. Mei Hui, no, sir. Ati said no, sir. Ati and Mei Hui, they do want to talk, so they type here. Okay, thank you, Ati and Mei Hui. Yeah. Form 4, so how are you all? Your parents worried or not? Because so far like this, your you know what time you can go back to school. I also cannot predict. The earliest is for the Form 5 student, it must be June already, 9th of June. That one is earlier, Form 5. Then Form 4, I don't know. Form 4, it can be September, October, then go back straight away, final exam already. Okay? Go back to school straight away, final exam, no, you're Form 4. No repeat one, you know, you won't repeat your Form 4 one, no. You don't think of, no, I don't need to study now, wait for the school open, then one teacher will teach, then you are very, very wrong. It won't happen like that one. All the students are from 1 to Form 4 actually, you're supposed to study at home now, you know, through online learning. Okay? You study as usual, understand? Don't wait for the school to reopen, then only you study. It's too late, you know. So when reach December, then it's holiday, then you go holiday now. So next year when you go back, you are Form 5 already. Okay? I hope it won't happen when you go back school, straight away it's final exam Form 4. Okay? That will be a disaster for you, no? You all must study, you know. Don't forget now. Don't play too much, you know. At least you set a target, one day you must study 2-3 hours at least. Okay? Plan your timetable so that every day you study. At least you study every day. Okay? Don't sit down there at home, do nothing. Then sleep until 1 o'clock in the afternoon, you wake up. I know some of you wake up very late one. Okay? Understand now? Nobody answer. Okay,
Understand.
So we move on now. Okay, it's your lesson 3. Okay. Okay, you see the title of lesson 3. Okay. Lesson 3, the title is another new thing for you, you know. Your lesson 2 was specific heat capacity. And now your lesson 3 become specific latent heat. This is L. Okay. If your lesson 2 specific capacity, the symbol is C, right? This one latent heat is L. Specific latent heat is L. Okay, it's L. So you learn something new this lesson, okay? It's an important topic, you know. All right. Close this paper first, Yeah, let's look at here. Okay. Ready or not, everyone? Okay. What does the word latent heat means? Please highlight. Latent, actually you find the dictionary means hidden, when you cannot see one, you know. Latent heat means hidden heat. Okay, highlight. Hidden means high up, you cannot see one. Why cannot see? I ask you later, you tell me why. Now you read first. The heat energy changes the state of the substance. Okay, changes the state of the substance means between solid, liquid, and gas. State of substances referring to solid, liquid, gas are 3 only. So the heat energy changes the state of the substance. Changes the state means can be changed from solid to liquid, can be changed from liquid to gas, right? Or reverse also can. Okay, that's called phase change. The heat cannot be seen. Cannot be seen because no rise in the temperature of substance. This is extremely important. Please highlight. Why we say latent heat, hidden heat cannot seen? Because this something happen, but you don't see the temperature when you don't see. That's why you cannot see anything. Okay, I'll give you one example. The ice solid, right? When the ice is melting, means the ice changing to liquid, correct not? Okay, when the ice in solid changes to liquid, the ice is melting. Do you see any heat there or not? You never see any heat, you just see the ice melt like that, no heat. Okay, but it's changing state, changing from solid to liquid. Okay, actually involving heat also, but the heat cannot be seen because no change in temperature. Because when the ice melting at the ice cube 0 degree, it changes to water, melt to water, the water also 0 degree one, because no change in the temperature. That's why we say we don't see any heat there when the ice melting to water, right? Become ice water. When ice cube changes to ice water, changing from solid to liquid, but the temperature remains 0 degree. The ice is 0 degree. The ice water also 0, 1. So no change in temperature. That's why we see you cannot see the change in temperature. That's why you see the heat cannot be seen. That's why we say latent heat, hidden heat now. Okay, But let me explain to you. Latent heat here means the heat energy needed to change the state of the substance. How much heat is needed to change 1 kilogram of ice in solid into water? That is called latent heat. Okay, but for now, you just remember here first. Latent heat means hidden heat. Heat energy changes the state of substance. The heat cannot be seen because no rise in temperature. Okay, there are a few steps you understand here first. Okay, changing of phase changings. When a phase change has occurred, latent heat absorb or release. Sometimes absorb, sometimes release one. You have to memorize. When is absorbed heat? When is released? Okay, you see here. From solid, it changes to liquid. Is fusion. Fusion, or we say melting. Melting is an English word, not scientific term. Scientific terms we call fusion. When solid change to liquid, we call fusion. Okay, melting now. Actually, you don't understand, you can put here is melting. Okay, during the melting process, right, latent heat of fusion is absorbed. Highlight this one important. When the ice is melting, right, actually absorb heat, absorb the latent heat of fusion. Okay, the ice absorb heat, then only the ice can melt. Understand? So during the process of fusion, solid change to liquid, like latent heat of fusion. Okay, let me clarify to you. Fusion means change from solid to liquid. Solid to liquid is fusion. Okay, then from liquid change to gas, that one is vaporization. Vaporization. So got two types of latent heat now. Latent heat of fusion and latent heat of vaporization. Okay, now you look at here first. Okay, another process when liquid go back to solid. This is solidification now, freezing, right? Okay, from liquid change back to solid. Solid is solidification. Here, latent heat of fusion is released. See, different, here absorb latent heat fusion. Then here release the latent heat of fusion. When liquid want to go back to solid, when the water want to freeze to become solid, right, is release the heat. Latent heat of fusion is released. Okay. Yeah. Okay. Next one. From liquid change to gas. This is vaporization. Vaporize. Okay. During this process, right, latent heat of vaporization is absorbed. It absorbs heat. But the name of the heat called latent heat of vaporization. I told you just now got two latent heat, right? One is latent heat of fusion. Another one is latent heat of vaporization. Okay? What is the difference name? Latent heat of fusion is changing from solid to liquid. Okay? Whereas latent heat of vaporization is changing from liquid to gas. Liquid go to gas. You see here. So it's latent heat vaporization absorbed here. Then from gas, it go back to liquid. Okay? This is condensation. Okay, from gas go back to liquid is condensation. During condensation process, right, latent heat is released. Latent heat of vaporization is released. So please be careful when the heat is absorbed, when the heat is released. Okay. Okay, remember this diagram. Okay. All right, next one. One more is from solid change to gas, direct one. This one never go through liquid. From solid, it changes to gas straight away. This is sublimation. I think you have learned, right? You have learned in lower form, sublimation. Sublimation means I can change from directly solid, direct go to gas one. Okay, sublimation. Okay, sublimation also like this. Solid one change to gas, right? It absorb heat. Okay, absorb heat. When gas want to go back to solid, it will release heat. Okay, yeah. Okay, now latent heat and kinetic theory. You learn this kinetic theory. Why something to do with kinetic theory, right? Okay, remember now when you see these terms, kinetic theory means got related with molecule. We are going to see how the molecule move, how the molecule vibrate, right? Okay, before this, I want you to look at this diagram first, okay? I think I use this diagram to you first, so that you have the basic, then later on you can understand easy, okay? Look at here now. First, when you look at solid, when during solid states, the molecules are very close. They are very close, attached to each other, right? So in between them, they have this force of attraction. Okay, they have force attracting them become very close. So this is solid. Okay, whereas liquid the distance become further. You can see distance between the molecule become further, meaning that these binding force are intermolecular. We call it intermolecular binding force. Okay, you see now, in the solid, the molecule and molecules they bind together very close, very strong. So this intermolecular binding force, we call it intermolecular binding force, is very, very strong. Okay, when it go to liquid this intermolecular binding force become weaker, weak already. This force attraction force become weak. That's why the molecule lose a little bit already. It go further. This one is in the liquid state. The intermolecular binding force become weaker. Okay, then go to gas. When go to gas means no more intermolecular binding force. Totally break already. This force totally break. No more already. No more intermolecular binding force. So it break free. The gas molecule are free to move around randomly. Understand? Okay, now I want to explain here. You listen. When changing from solid to liquid, okay, from change to solid to liquid, what happens is this now. You need energy to break the force. Okay, this force is very strong, binding them together, right? To change to liquid means you need to break the force, break this force so that this force become weaker. When the force becomes weaker, then the molecule can go further apart from each other. Okay, now the reason is what? During changing from solid to liquid, right? For example, ice, solid, you want to change to water, right? Okay, ice want to change to water, you absorb heat, right? Not, you see here, solid ice want to change to liquid water, right? Absorb heat, later here fusion. Okay, from here to here, absorb heat. But heat is absorbed, but how come the temperature never go up, never change in temperature? So now we know already, right? During the process of changing state, no change in temperature one, So ice change to water, temperature is 0, remains at 0. Okay, the reason is here. The heat is absorbed and then used to break the binding force between the molecule. You break this binding force, break the force so that the force become weaker, weaker. When weaker force, it will go further apart. So meaning that the heat energy is used to do other job, used to break the binding force. So meaning that it won't increase the temperature because it's used to do other things with the heat. Okay, heat is used to break up the binding force between the molecules, so it becomes liquid, right? That is the reason. Okay, another one is from liquid change to gas. Now, even stronger, you see that? This one you still have a little bit of binding force here. Now you want to totally break the force, break the force so that the molecule are free to move already, no more binding force. Means you need another energy to break this binding. That energy is called latent heat of vaporization. You absorb the heat, but the heat energy is used to do what? Used to break the binding force between the molecule liquid, so that the molecule become free to move, no more attached, no more binding force. Understand? So roughly you know all this already. This three diagram is very important, This is called kinetic theory. Okay, when you see the word kinetic theory means explain from the aspect of molecule. Okay, right? Okay, now we start here. Latent heat and kinetic theory. For essay question, you need to understand you have to go through. In solid, highlight, the molecule are linked to the neighbors by forces of attraction. I told you just now, forces of attraction, the intermolecular binding force. As the solid is heated, okay, what happened now? Go here. We cannot see. Okay, now as the molecule vibrates more strongly. When you heat the molecule, heat up, right? So the molecule vibrates strongly. When a solid reaches a melting point, you want to change from solid to liquid already, right? The vibration has become so strong that the link begins to give way. Give way means loss, become a loose already. You see here? Look at the diagram. Here, the binding force very strong. But now, because vibration is too strong, it vibrates too fast, right? So until this binding force started to give way. Give way means give up already. So give up, lose already. So it become like that, loose. Okay, the binding force become loose. Okay, yeah, the vibration has become so strong that the link begin to give way. Okay, extra energy needed to overcome these forces. Okay, and separate the molecule. Okay, separate the molecule like that. From here, very close. You want to separate them. Okay, this is called latent heat of fusion. Okay, from solid change to liquid fusion. No temperature rise, highlight, occur during this process. No temperature rise because latent heat of fusion is used to overcome the intermolecular binding forces. Means the heat absorbed not increase the temperature. The heat absorbed is used to overcome the intermolecular binding force to make the molecule, the force become weak, so the molecule become move away from each other. The average translation kinetic energy does not change. The kinetic energy does not change, okay? That's why the temperature remain constant. This paragraph very important, okay? In the liquid here, right? Molecules are free enough to slide around. They're free enough to move over each other, okay? But not totally free yet, and change neighbor. But they are still almost as close at each other in the solid, still considered close, This is very close. This one is still considered close a bit, The link are weaker, now weaker. The link are weaker, the binding, but still effective, are still holding them, The links are weak, but still effective holding the molecule, okay? As the liquid heated further, kinetic energy of the molecule increases, the molecule move faster, right? At boiling point, the molecule break free. Now break free, totally break already. This binding force no more. Break free from each other and become a gas. Energy needed to overcome the remaining link. You need energy to break totally the link. Need energy to break the link. Energy needed to overcome the remaining link. This is called latent heat of vaporization. Okay, remember that. No temperature rise. During this process from here change to here, no temperature. Okay, you must know our class. During solid change to liquid, this is 0 degree. I think example, ice into water, 0 degree. Huh? Then for water, when you change to gas, right, the temperature must be 100 degree, boiling, evaporation. Boiling point is 100 degree. During water change to gas, is boiling, right, the temperature remains as 100. Never change. This one remains as 0. Here to here, the temperature remains at 100 degree. No temperature rise because during this process, latent of vaporization used to overcome symptoms are overcome the intermolecular binding force, to overcome this force, to break the force. So the average translational kinetic energy does not change. The kinetic energy does not change, so it means temperature never changes. Okay, you understand? A lot of theory here first and all. Later on, only we start doing the calculation. Okay. So far, how? Okay or not? Can understand now? Nah, pause you may. Can understand? Pause you may. Pause you may. Can understand or not?
Can.
Can. Can one you? Where is your friend? And there was can one you? Where are you? Can one you? Never see her name. Can one you? Jin Yi Hong. Jin Yi Hong. Understand?
Understand.
Understand. Okay, good. Thank you. Hong Chao Xiang. Understand?
Understand.
Okay, thank you. Lao Yixin. Understand? Lao Yixin. Lao Yixin, no more sound there. Kathleen Yao. Understand? Kailin Yao. Kailin Yao.
Understand.
Understand? Okay. Kaman, what about you? Kaman? Kaman, understand?
Understand.
Okay, good. There you go. There you go. Do you understand?
Understand, sir.
Okay, okay, let me see some other people here. Kang Ng Wei Kang, is it? Ng Wei Kang? Ng Wei Kang, do you understand? No sound. This time maybe he doesn't know I call him. Lim Ching Wen, okay or not? Lim Ching Wen?
Okay.
Okay, Mei Hui, okay or not? Mei Hui, she don't talk one, she will type only. Okay, never mind. Okay, Sim Pun Keng. Sim Pun Keng. Sim, are you there? Sim Pun Keng. Sim Pun Keng, I miss him very much. A long time never see him. Gan Wan Yu. Okay, Gan Wan Yu, okay, understand? Gan Wan Yu. Only people don't know now because your face never appear here. Don't know you are in or out. Okay. Lim Si Liang. Lim Si Liang, are you there?
Yes, sir.
You got any question to ask or not? Si Liang?
No, sir.
No, sir. Okay, thank you. Cherish, anything to ask? Cherish?
No, sir.
No, sir. She only say one word. No, sir. Every day I ask her, she keep the same answer. No, sir. Cherish. Okay. Very shy. Lim Pun King say yes. Gan Wan Yu, teacher, what is Gan, you ask question here. Just ask you never answer. No. Okay. Teacher, what is average translation kinetic energy? Okay. When you see the term just now, right? Average kinetic energy means is the kinetic energy lah. Understand? Average kinetic energy, when you absorb the heat supposed to make the kinetic energy more because when heat energy is absorbed, it's supposed to be the molecule move faster one, So kinetic energy should be more. But in the case of this, because that's what I say, the heat energy is absorbed to do something else, right? To break the intermolecular binding force. So this will not change the average kinetic energy. So the kinetic energy remains the same. Okay, you don't need to know what is translation. Actually, same one. You just remember average kinetic energy. So the average kinetic energy remains the same. Means the molecule still never move faster, still the same. Because heat energy used to do something else, used to break the intermolecular binding force. So not make the molecule move faster. So the kinetic energy remains the same. Can you understand? Now she said, okay, thank you, teacher. Okay, can you? Thank you. Any more questions here? Clement, are you here now? One is Clement. Yeah. Okay, we go and a little bit more. Okay. Heating curve. Okay, see here. Okay. This one is heating curve. You heat up something, you see now. This thing at the temperature, when you heat up, right, the temperature 30 go to 80. So here, heat up. So here is solid, you see, solid. A to B, solid, I highlight now. Solid means the temperature go up from 30, go up to 80. 80 is a melting point. So here, melting. BC, solid plus liquid means started to melt. Some solid, some liquid. So started to melt. Melting point 80. When everything melted already, then the temperature continue to go up. CD is liquid. Because all the solid melted already, now all become liquid. So you continue supply the heat, so the energy go up, so the heat go up, 218, right? Then here, you want to change to gas already. So DE here, this one is boiling point, okay? It's boiling point. Boiling point is 218 degrees. Start to boil. So changing to liquid, change to gas. Here got liquid and gas. No, you see here, liquid and gas. So parts of it still remains liquid. Another part change to liquid already. Okay, change to gas already. So here, from here to here now, the liquid wanted to change to gas until here, all finished change to gas already, and then the temperature continue to go up. So here is solid. Here liquid, solid, half. Here all liquid, temperature go up. Here liquid and gas. Okay, campur. Then here all gas. You understand the graph? Okay, now there are a few things you need to understand. Why here AB, CD the temperature go up? AB, CD, and EF the temperature go up. Why BC, DE temperature not going up? You must understand it all. Okay, now you see. Why at this point here, AB, CD, EF the temperature go up? Can you read the whole paragraph to understand it? Why temperature go up? Okay, the heat supply increases the kinetic energy of the naphthalene. When you supply the heat, right? The heat increase the kinetic energy of the molecule, so the molecule move faster, right? So the temperature rises because temperature is a measure of average kinetic energy. Means when during these few parts here, A, B, C, D, E, F, right, you supply heat, then the heat is used to increase the kinetic energy of the molecule. When you increase the kinetic of the molecule, increase the kinetic energy of the molecule, right? Now the molecule vibrate faster, got more kinetic energy, move faster. So it will increase the temperature. The temperature rises because temperature is a measure of kinetic energy. Means when you have more kinetic energy, the temperature is higher. Okay, when your kinetic energy does not change, means the temperature does not change. Understand? Okay, for this viewpoint, you must know why the temperature go up, because heat supply increases the average kinetic energy of the molecule. That's why the temperature go up. Okay, what about BC, DE, why temperature never go up? I think I already explained to you just now. Okay, let's see what's the explanation. Why temperature never go up? Okay, you read here. Make sure you understand. BC, DE, right? T1, T2, phase change occur. Okay, phase change occur means either change from solid to liquid. Another one is changing from liquid to gas. The phase change occur here. Okay, then latent heat is absorbed, still absorb the heat, but do some other thing to provide the energy to overcome the binding force between the molecule. Remember, the energy is absorbed, but not to increase the kinetic energy, is to overcome the binding forces between the molecule. Want to break the binding, make the binding loose. Okay? So the energy absorbed does not increase the kinetic energy. So when kinetic energy does not increase, means temperature remain constant at that particular place. Understand? Okay, Okay, another one is cooling curve. Cooling, cool down. Okay? Here, cool down to 180. And then here is gas. Look at here. AB is gas, very hot. It's in the form of gas. Then BC here start to become liquid condensation. So half is gas, another half is liquid. Okay, gas plus liquid. So here condensation happen now. Solidification, not solidification yet. Okay, condensation. Okay, when all to become liquid already, CD liquid, then the temperature drop. From 218 drop to 80, CD all liquid. Then when reach 80 degree, it start to become solid, solidification. Okay, so here half solid, half liquid. Okay, liquid solid. And all change into solid already, then temperature drop to 30. Okay, this is a reverse process like just now. Okay, same thing, question we ask. Freezing point at T. Here is condensation point. Why here, here, temperature drop? Why here and here, temperature does not drop? I ask you to explain, Why? When you cool down, why here, cool down, temperature drop. Why here, why never cool down? Heat is released, but why the temperature remains the same? Same answer, like just now, you see, Okay. A, B, C, D, E, F, right? Now heat is, when cool down, right, you release the heat, Heat relates to the surrounding and the kinetic energy decreases. Okay, remember now, when you release the heat, right, so your kinetic energy becomes less. Kinetic energy is less. Okay, so kinetic energy of the molecule decreases. When kinetic energy rests, right, less, so temperature will drop, resulting in the fall in the temperature, because temperature is a measure of kinetic energy. Okay, understand now? So during A, B, C, D, E, F, the reason of temperature drop is because heat released to the surrounding. When heat released, it will make the kinetic energy drop. Less kinetic energy, so the temperature drop. Understand? Okay, most important is here, B, C, D, E, why temperature never drop? Okay, the reason is at T1, T2, right? Phase change occur. Phase change means a change from gas to liquid, or change from liquid to solid happen. So the latent heat is still released, but latent heat is released to the surrounding as the molecule become more closely packed. Okay, I want to explain like this. Actually, it's like this, The latent heat is released, right? But it doesn't actually release to the surrounding. Because you know why, when from gas you want to go back to liquid, mean the molecule must become closer. Gas is very far, man. Just now you see right here. The gas the gas are all free to move on. When gas want to change to liquid, condensation, right? So meaning that you need energy to pull the molecule back one, like this. Yeah, you need to use energy to pull them come back, pull this molecule come back closer to become like that. This is what mean by the statement. Heat is released, but it doesn't go to the surrounding. The released heat is used to do what? To pull the molecule go back to closer distance to become liquid. Understand? Understand? So remember now, heat is released, but the heat is used to pull the molecule so that they become closer to form the bonding now. Okay? Understand? This actually does not reduce the molecule, does not reduce the kinetic energy. That's why the temperature remains the same. Another one means you see from gas you go back to liquid closer. Now the molecule, the kinetic energy actually become more already, right? Right? So this will prevent the temperature from further drop. Understand? Yeah. It's here. Okay. Latent heat relates to surrounding as a molecule become more closely packed. More closely packed means that you need energy to pull the molecule come. The energy must come from the energy release. So the energy release does not decrease the kinetic energy. This is a statement, no? The energy release does not go to the surrounding, actually. It doesn't go to the surrounding. That's why the kinetic energy not decrease. So temperature remain constant. Okay? The energy release is used to make the molecule become more closely packed, to pull the molecule become closer. That's why energy release does not decrease the kinetic energy of the molecule. So the temperature remain constant. Okay? Understand? Okay, 10 o'clock already lah. I think I don't want to talk so much already lah. So I think I want to put a full stop for today here. Okay. On Wednesday only, I will go into more detail for the calculation part is on Wednesday. Okay. So far, can you understand today's lesson or not? Amanda, where are you? Amanda, you understand today's lesson?
Yes, sir. Yes, sir.
Yes, sir. Marvin, where are you? Marvin.
Yes.
Marvin, Marvin,
Yeah.
do you understand today's lesson?
Yes.
Can Jing Wen, okay or not?
Okay.
Okay, Tan Cho Ming, understand? Justin, you got anything to ask or not? Justin Yip?
Teacher.
Yes.
If during the exam the binding force are right, force of attraction can.
What? Say it again.
If the binding force during the exam are right, force of attraction, will the answer accept or not? Can. Okay.
Force of attraction between the molecule is the same lah.
Same,
intermolecular binding force, or we just say force of attraction between the molecule. Okay.
Okay.
Also can okay, Justin. Any more
okay,
questions, Justin? No more. Juling, any question to ask, Juling?
No, sir.
No, sir. Okay, if no question, okay, remember class, make sure you have a proper plan, proper timetable at home. It's still a long time before you can go back to school, You all must set a proper timetable to study at home, okay? Form 4 is very important for you all for next year, for your SPM, because I can tell you that the Form 4 syllabus and the Form 5 syllabus is equally important for your SPM. Or you don't say that for SPM only Form 5 important. No. I tell you, in the SPM question, very accurate one. Half of the question come out from Form 4 one, another half come from Form 5 one. So equally important one, you know. So you don't miss any lesson of your Form 4, okay? So even though now you cannot go back to school, but you don't stop learning, don't stop study. Remember, continue to study at home. If your teacher give you online class, YouTube video, ask you to watch, ask you to learn, right? Please go and follow, understand? Don't take for granted. I wait for the school to open, and then you are too late already. I tell you, when you wait for the school to open, your teacher won't repeat again. Your teacher will continue to teach or the online lesson, everything that the teacher will continue to teach one, you know, won't repeat one. Okay, if online lesson stop at chapter 4, I mean when school reopen, the teacher teach chapter 5 already. Okay, so please tell all your friends, organize a study schedule to study properly at home. I know even if you are Form 4, but don't forget Form 4 is very important. Okay, 2 years only, 50% Form 4, 50% Form 5. Okay, Form 5 you don't think wait until Form 5 only you go and study Form 4. I tell you, no time, man. Form 5 you are busy enough to catch up the Form 5 syllabus. No time for you to turn back to go and study your Form 4 syllabus. Form 4 means you study this year, you go and learn now. Next year, you focus to your Form 5 syllabus. Okay? Understand? Okay? So plan your time at home, at least 2-3 hours per day minimum. You study every day at home. Okay? Right. Thank you very much. Thank you everyone for coming here. Okay, I see you on Wednesday again. Okay, bye-bye. Bye-bye.
Thank you, sir.
Thank you, sir.
Bye.
sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.
Bye-bye. Bye-bye.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Okay, bye-bye. Bye-bye.